So Friedel Crafts alkylation reaction. What is step number 1? Generation of electrophile. So in generation of electrophile, we will use anhydrous AlCl3, aluminum chloride. To this, I'm going to treat it with CH3Cl. So this chlorine along with electron will go to aluminum chloride and forms AlCl4 minus plus CH3 plus, which is called as methyl carbocation. Step number 2, rhenium ion mechanism. So what will happen in this case? Take benzene ring, treat it with the methyl carbocation. So the electron from the benzene ring will attack it. So thereby you get and there will be a positive charge created. So when this moves over here, we'll get a double bond here, and then an hydrogen, and then a methyl here. Again this will move over here. The next step, hydrogen over here, and then a positive charge. So this rhenium ion will be in resonance. I told you how you can write all together. You can write like this: a positive charge here, and hydrogen, and then a methyl. What is step number 3? Regeneration of catalyst. So what is the formula of the rhenium ion? With the 2 pi bond, 1 hydrogen, and then 1 methyl with a positive charge over here. Now we have AlCl4 minus. This will attack the hydrogen and the bond will go over here. So you'll get a benzene ring with all the bonds and the methyl plus HCl plus AlCl3. So hydrogen is also regenerated. The catalyst is also regenerated. Hydrogen also got removed. So it is also called as deprotonation. Are you making note of it? Hello, Rifa, are you there in the meeting?
Yes, sir.
Yeah, copy ma. So in Friedel-Crafts acylation reaction, step 1, aluminum chloride reacts with acetyl chloride to give AlCl4 minus and CH3CO plus, which is called as acetyl carbocation. Again, in this step number 2, acetyl carbocation is attacked by the benzene and forms rhenium ion mechanism. In the third step, the AlCl4 formed in the first step attacks the proton, thereby deprotonation takes place and regeneration of AlCl3 takes place, formation of acetophenone as major product. Please make a note, ma. So benzene will react with platinum, hydrogen or palladium and form cyclohexane, which is reduction. We call this reaction as what, ma? Reduction reaction. When you do add the chlorine to it, it is called as chlorination and it forms something called gamexane. Gamexane is a very powerful insecticide. It's also called as benzene hexachloride. When you treat it with oxygen in presence of vanadium pentoxide at 773 Kelvin, you'll get something called malic acid. On further heating, malic acid will lose its water and form malic anhydride. Finally, when you treat it with nickel or lithium in presence of liquor ammonia followed by treatment of alcohol, you'll get 1,4 cyclohexadiene, which is called as Birch reduction. These are all the addition reactions of benzene. Please copy. Once you are done copying, let me know. We'll go for further reactions. Finished, Amma? Shall we move forward?
No.
Make it fast. Aspect of benzene ring, that is when a particular group is attached to a benzene ring, what will happen to the incoming group? For example, if this is your benzene ring, okay, and I have OH attached, now I'm going to do chlorination. So I'm going to add FeCl3 in presence of Cl2. Now what is the question? Where will the chlorine go? Remember, this OH is an ortho and para director. So ortho means these two positions are ortho, these two positions are meta, the opposite position is para. So what will happen? The incoming chlorine will go to the ortho position or it will go to the para position. It will not go to the meta position because OH is a ortho para director. So you'll get orthochlorophenol or parachlorophenol, and remember both you will get, this is major, this is minor, because for the incoming group, better the molecules dipole moment. So dipole moment will be lesser the dipole moment, more the stability. Other way, if you have a group called nitro group, NO2, for example, you take NO2 group And if you treat this molecule with same, you just try to do same chlorination. But remember, this time nitro group is a meta director. So you don't get any ortho or para compound, you'll get only pure meta product. Please make a note. So where will the incoming group will go? It will go to the meta position over here. And this is the only major. So this is your phenol. This is your nitrobenzene. So what group is attached to benzene? Based on it, the incoming group will go to that position. Now the question is, what makes them to do this kind of action? Let us see why. There are certain directors are called ortho and para directing group. Ortho and para directing group, and they are also called as ring activating group or ring activators. Okay, so what will happen? For example, you take benzene itself, phenol itself you take. So the OH group attached to the benzene is called as phenol. So the lone pairs will be given to the benzene ring. So what will happen in the next case? The other two electrons will be there. The electron from the OH has come down. So there is a positive charge here and then there is a negative charge over here. What will happen? This negative charge will enter into the benzene ring. Thereby the old electron will go and occupy the ortho, para and again ortho position. If you check, that is how it will be. Okay. Again it enters the ring, it goes to the ortho position. Again it enters the ring, it goes back. So if you look at the positions, you know electrophile is positively charged, correct? Am I right, Rifa?
Yes, sir.
So what happens? Where it will go, the electrophile will go to the place where it is more electronegative. So according to the ring, where is the negative charge present? Either in the ortho position or in the para position. So where does the electrophile goes? Only to the ortho and para. Now you understood what is the reason?
Yes, sir.
If you look at the, so that is why it is going to the ortho and para. Now you check for the nitro group. Nitro group is a meta directing group. Meta directing group means they are also called as ring deactivating group or ring deactivators. So now let us see how the nitro group is going to work. I will give time for you to copy. Just look at the molecule. Later we'll copy. So now what will happen? I said benzene ring is there. N double bond O minus. This is a coordinate bond. Now it is beyond your scope, so don't worry. So this electron moves here and this goes over here. So you'll get a benzene ring over here. Double bond N O minus with a coordinated O. Now where is the positive charge? Here is a positive charge. So now it moves over here. Now in the next step what will happen again? There is a double bond over here. Double bond N O minus with a coordinated oxygen. There is a positive charge again. Again this will go here. In the next step what will happen again? The double bond is here. Double bond N O minus coordinate O and there is a positive charge here. Again it enters the ring and it comes back. So this is how the resonance will be. So if you look at this particular resonating structure, if you look in all the ortho positions, what is there? Delta plus. all the ortho and para portion delta plus. Correct? That means
Yes, sir.
the negative point is only in the meta position, and we know electrophile will go to the negatively charged space. That is why it is a meta director. Okay, so who are all ortho directors, who are all meta directors? I will just write, you can also add them. So we have OR, we have CH3, we have CL, we have BR, we have I, we have NH2. Okay, these are all, please make a note, these are all ortho and para directors, as how your phenol does. Similarly, if you come here, we have CN, we have CHO, we have C double bond OR, C double bond OH, C double bond OR. Like that, you have many groups. All these groups are meta directors, perfectly meta directing group. NO2, whatever. Okay, these are all meta directors. Okay, copy ma. First write this reaction, followed by that you go for the other diagrams. Any doubts? Rifa, are you there in the meeting? Any doubts?
No, sir.
Okay, because this resonating structure people struggle. That's why I'm asking again and again. So if you're able to find the resonating structure easier, good. If not, you can ask me, I can reteach, not a problem. Okay? And you have to practice too.
Okay.
So basic concepts of organic reaction.